Hello everyone, welcome to the next session on Advanced ANSYS Workbench tutorials. In this session, we will analyze a branch pipe for its static structure analysis. We will start by double-clicking on static structural module. Then we'll go to engineering data and double-click. Engineering data sources, general materials. We'll choose stainless steel as one of the material. Again, I'll click on engineering data sources. I'll add one more material. I'll choose HDPE as the other material. I'll give the value of density, which is 995 kg per meter cube. Also, I'll give the value of isotropic elasticity. Young's modulus is 1.5 gigapascal, so E9. Value of Poisson's ratio is 0.45. I'll go to project and update project. Next, I'll go to geometry and right click. I'll import the geometry of the branch pipe. I'll go to model and double click. I'll first go to geometry, solid. I'll change the material to stainless steel. Next, I'll go to mesh and generate mesh. I'll go to static structural, right click, insert, fix support. I'll use a face option. I'll select this face, apply. In the inner surface, I'm going to apply pressure, so I'll select all of them. Right click, insert, pressure. I'll give a pressure of 0.5 megapascal. Next, I'll go to solution, insert, deformation total. Again, insert strain equivalent and insert stress equivalent. I'll go to solution and solve. First, we'll go to total deformation. If you don't want to see the elements, you can go to edges, no wireframe, contours. I'll choose smooth contours such that the colors blend into each other. So this is how the branch pipe will look like. Maximum deformation is 34.537 mm, which means it is quite high value. So we need to change the value of pressure. I will take this as 0.01 megapascal. I'll go to solution and solve once again. I'll first go to total deformation. Maximum value is 0.69 mm. So now you can see the value has reduced. So this pressure is okay for this pipe with the material stainless steel. This is how it will look like when I animate. Then we'll go for the strain value. You can see the maximum strain is 0.00015. Minimum is 1.02 into 10 raised to minus 6. You can see here, this is the zone where the strain is going to be more. In these zones, it is going to be less. You can animate and check this. The animation will be the same. Then we'll go to equivalent stress. You can see the maximum stress is 27.572 megapascal and the minimum is 0.05. If you want, you can click on max min to know where the value is maximum and where it is minimum. Now I'll go to solid and change the material to HDPE and solve once again such that we can get the results for another material for this pipe. Now we'll see the total deformation. You can see again the value has increased to 77.754 mm, which means for this pipe using HDPE as a material, this pressure has again become a high value. So we need to reduce it to 0.00 0.01 say megapascal. I'll solve once again. If you click on total deformation, you will see it is 0.777 mm, which means the value has reduced. So this value of pressure is fine for this material and this pipe structure. Minimum is 0. Then we'll go to equivalent elastic strain. Value is 0.00017. Highest value. Minimum is 9.5 to 10 raised to -7. You can see here which is the max and which is the min point. Then we'll go to equivalent stress. The highest value is 0.22 megapascal, which is quite small value. So obviously your pipe is going to be completely safe under this pressure. Minimum is 0.0013 megapascal. You can again see where it is max and min. If you don't want to see the max and min point, you can just click on max and min once again. If you want to see these values in between, click on probe and you can go to these points and you can click at the point where you want the value. You have got these values. Say you don't want to see them, right click, delete all. So they will be removed. So you can just get the values that you want. So that's how you analyze a branch pipe for its static structural analysis. I hope you've understood the analysis. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.